Hey there, science fans! Ever wondered how computers speak our language? It's all about numbers. But computers don't use the same system we do. We use decimal with 10 digits, 0 to 9. Computers use binary with just 2, 0 and 1. Think of it like a light switch. It's either on, 1, or off, 0. These ones and zeros form the building blocks of everything digital, from the websites you browse to the games you play. Now let's convert from decimal to binary. Imagine dividing a number by 2 repeatedly, keeping track of the remainders. Let's try it with the number 13. 13 divided by 2 is 6 with a remainder of 1. 6 divided by 2 is 3 with a remainder of 0. Keep going until you hit 0. You'll get a sequence of remainders, 1, 0, 1, 1. Read them from bottom to top and voila. 1101 is the binary equivalent of 13, but that's not all. Computers also use octal, base 8, and hexadecimal, base 16. Octal is like counting in groups of 8, using digits 0 to 7. Hexadecimal uses 0 to 9 and A2F to represent values from 0 to 15. These different systems may seem strange at first, but they are all just ways of representing numbers. And once you understand the code, you can unlock the secrets of the digital world. Now, let's talk pixels. Imagine a mosaic made of tiny squares, each with its own color. That's how digital images work. These squares are called pixels, and they're the building blocks of every photo, video, and graphic you see on a screen. The more pixels you have, the sharper the image. Think of it like this. A high-resolution image is like having a front row seat, while a low-resolution image is like sitting way in the back. But how do pixels get their color? That's where RGB comes in. RGB stands for red, green, and blue. By combining different intensities of these three primary colors, we can create millions of different shades. Each pixel is like a tiny light bulb, emitting different amounts of red, green, and blue light. When these lights mix, they create the colors we see. So next time you're admiring a stunning digital image, remember the millions of tiny pixels working together to create that visual masterpiece. Music, sound effects, even your favorite podcast, it's all just vibrations in the air. But how do we capture these vibrations and turn them into something a computer can understand? The answer is digitization. Imagine you're measuring the height of a wave at regular intervals. That's essentially what happens when we digitize sound. This process is called sampling. The more frequently we sample, the more accurately we capture the original sound wave. Each sample is then assigned a numerical value, representing its amplitude or loudness. This is called bit depth. The higher the bit depth, the more detail and dynamic range we can capture in the sound. Think of it like having more shades of grey in a black and white photo. So, from vinyl records to streaming services, every digital audio experience relies on this incredible process of converting sound waves into numbers. Ever wondered how devices on the internet find each other? It's like having an address for your computer. Every device connected to a network needs a unique identifier, and that's where IP addresses come in. Think of an IP address as a phone number for your computer. Just like we use phone numbers to call each other, computers use IP addresses to send data back and forth. These addresses are made up of a series of numbers separated by dots. There are two main types of IP addresses, IPv4 and IPv6. IPv4 addresses are like the old landline numbers, while IPv6 addresses are like the newer mobile numbers. IPv6 was introduced to accommodate the growing number of devices connecting to the internet. So, whether you're browsing the web, sending an email, or streaming a video, your device is using its IP address to navigate the vast network of the internet. It's like having a digital passport that allows you to communicate with the world.